AFSID system, if a 20 kilometer reel of bare fiber is terminated to the instrument, the reel of fiber can easily pick up people whispering from across the room. This extreme sensitivity to acoustic waves can have a disadvantage when trying to identify a fiber optic cable. Seismic disturbances caused by trains and road traffic can produce a high level of background noise, making it difficult to pick out the tapping signal. In addition, high sensitivity can also allow crosstalk to produce false positive test results. Because cable jackets are rigid, mechanical disturbances introduced to one cable in a bundle can be coupled to the other cables. For this reason, the AFSID system incorporates advanced signal processing circuitry to drastically reduce noise and crosstalk. Noise reduction is user-selectable and provides excellent results as well as greater immunity to crosstalk, but at the expense of reduced sensitivity. Using the AFSID is very simple, but requires a minimum of 2 technicians. One technician sets up and monitors the instrument at a central office location. The other technician travels to the remote location where the cables need to be identified. This is usually in a vault or a manhole. For convenience, a third technician may stay at the remote end of the cable span to connect the loopback jumper or connector to the appropriate fiber ports and move the jumper if required. Alternatively, loopbacks may be placed on selected fibers in all cables to be tested by the field technician before traveling to the site where the locate will be made. The instrument is terminated to a pair of spare fibers in the cable to be identified using 2 FC jumpers. Before making any optical connections, it is important to clean each connector plug to prevent contamination of the patch panel ports or the ports on the AFSID. If your patch panel uses connectors other than an FC, you will need to use a set of hybrid jumpers. Connect the jumpers from the optical ports on the rear panel of the instrument to the appropriate ports on the patch panel. Connect the headset to the microphone and speaker jacks on the front panel of the instrument. Connect the stereo extension cable to the phone jack on the front panel and then to the headset port of a cellular telephone. Connect the power cord to the rear of the instrument and switch the instrument on. The instrument will initialize and perform a series of self-tests which take approximately 10 seconds. When complete, the low noise and the saturation alarm push buttons will illuminate, indicating the instrument is ready for operation. The field technician accesses